Hello everyone, welcome to yet another episode in Grind 75, a Better Blind 75 coding series. Let's jump into today's problem. So today we are going to work with the least common ancestor of a binary search tree. So we are given a binary search tree and we have to find out the least common ancestor. So I'll come to what the least common ancestor is. Let's quickly open the problem statement and start solving. So last time we had already solved flood fill. Today we are at least common ancestor of a binary search tree. Let's quickly go through the problem statement. Given a binary search tree, find the least common ancestor node of a given node in the BST according to definition. Okay, great. They have already given a definition for everyone of least common ancestor. The lowest common ancestor is defined between two nodes P and Q as the lowest node T that has both P and Q as descendants, or you can understand them as children. Okay, so 6 is the parent node. It has children nodes 2 and 8. Similarly, 2 is a parent node of 0 and 4, 3 and 6. 4 is a parent node for 3 and 5. 8 is a parent node for 7 and 9. But 6 is a overall ancestor for all of these other nodes. Now we have to find the least common ancestor. So if I pick 7 and 9, the least common ancestor for them is 8. 6 is also a common ancestor for 7 and 9, but 8 is closest to them, right? So the least common ancestor for 7 and 9 would be 8. Similarly, if we check for 0 and 5, for 5, 4 is the parent node. For 0, 2 is the parent node. 2 is also the parent node of 4, hence for the 5 as well. So least common ancestor node for 0 and 5 will be 2, because this is where they are aligned. So least common ancestor can be found out as the parent node which has both the child nodes, right, P and Q. And then we have to find the least, means the smallest one, right? If 3 and 5 are P and Q, 4 is the answer. 0 and 5, 2 is the answer. 0 and 7, 6 is the answer. Hope that is clear with everyone. So let's start solving. Now before we start solving, the problem statement is quite clear with everyone. We'll just go through it one more point. That is, now how will we solve it? Please take a minute, pause the video and think of the approach that we are going to take to solve this. Okay, let's start. So if I start from 6 and I'm given 2 and 8, so 2 is here, 8 is here, right? What I will do is I want to recursively check from 6 for the left hand side tree and from the right hand side tree. Then for 2 on the left hand side tree and for 8 on the right hand side tree. Similarly for 0, 4, 3, 5, 7, 9, right? But where will it stop? Okay, let me start and then you'll get to know where will it stop. So firstly we need few base conditions. Always remember there are always few base conditions. Always think of the base conditions first. What if the given root is null? So if the given root is null, we can return the root as the parent, or we can return null. Since root is null, we can return root, right? So base conditions would be if root is null, return null, right? Similarly, if root matches with either P or Q, return the root. Why? So let's say given P was 6, Q was 8. What could be the least common ancestor for them? 6 itself, right? Because 6 is containing 6 as well as it is containing 8. Similarly, if we were given 7 and 8, we will say 8 is the least common ancestor for both of them, right? Similarly, if we were given 2 and 5, we will say least common ancestor is 2. So we are going to check if the root node is either of P or Q, because if root node contains the value of P or it contains the value of Q, we can simply say that is the least common ancestor node, right? We are going to call this function recursively. That's why we need this check for every recursive call. Okay, let's put it, if root is equal to null, or root is equal to p, or root is equal to q. In either of these cases will return root. So for root equal to null, we should return null, but since root is in itself is null, we can return root. If root is equal to p, the first node, so if first node was 6, between 6 and 8, 6 in itself is the least common ancestor, so we can return the root. If root is equal to q, so let's say p was 2, q was 6, again between 2 and 6, 6 is the least common ancestor, and we'll return the root itself, right? Now we are going to recursively check for the children node as well. So recursively search for p and q in the left and right subtree, right? So I can say tree node left is equal to, we'll call this function again lowest common ancestor, lowest, why is it not coming capital, common ancestor, right? Will pass. Now I want to recursively check for this side as well, right? So I'll say for the checking for the left side, I'll say root dot left and then pass p and q. Similarly, we'll recursively call the method for the right side subtree as well. So we'll say lowest common ancestor will pass root dot right p q. Okay, then for this we started with 6. The values given p and q are 2 and 8. We'll check if root equal to null. No. Is root equal to p? No. Root equal to q? No. Return root? No. So the code will not come to this loop. Then we are going to search recursively for the left subtree. So in left subtree we are calling the lowest common ancestor function again, and we are passing root dot left. Root dot left is 2. What is the value of p? Value of p is still 2. What is the value of q? Value of q is still 8, right? So we start from here. 2, we check if root equal to null. No. If root equal to p, yes, root is equal to p, right? So let's return the root from here. So our left node will get the value 2 for this example use case, right? Similarly, we are going to call on the right side subtree as well. We'll pass root dot right, which is 8, and p, which is 2, q, which is 8. Among them, again this check will be done. Root equal to null? No. Root equal to p? No. Root equal to q? Yes, because root is 8 and q is 8. So we return root, which is 8. So we got 8. So from our lowest common ancestor on the left subtree, we got 2. Lowest common ancestor on the right subtree, we got 8, right? Now we are going to check. What should we check now? So we'll say if one of the subtree doesn't contain, okay, why? Okay, let me write it and then explain. Doesn't contain the least common, we'll say least common ancestor, return other subtrees result. Okay, so we checked this way, right? So we checked for q was 8. Imagine that value of p was 7 when we were calling for the right subtree. Root dot right was 8, q was equal to 8, but imagine p was equal to 7, right? So we simply returned, since we found either p or q, we simply return 8, right? Because 8 can be the ancestor node, least common ancestor node. But we do not know if 7 is there in this node or if 7 is going to come up in the next one, right? So now we will simply check if 7 is not part of this next left hand side tree, that means this is 8 is our right answer. Similarly, if 2 was one of the value of p was 2 but value of q was 5, it would not be available in the right subtree, and from left subtree we got the head as 2. So we'll check if 5 does not exist in this right subtree, this is the answer, right? Because between 2 and 5, 2 is the answer. So how will we check it? We'll check it with the simple use case. If left is equal to null, we'll say return right. Now when will it happen? So let's say I'll just denote value of our p was equal to 7, value of q is 8. Okay, we started from we'll start from 6. Okay, we started from 6. We checked if root equal to null, root equal to p, or root equal to q. No. We checked for the left subtree, lowest common ancestor. We passed root dot left 2, and value of p and q is 7 and 8. So we arrive with the 2 as the root node. We check if root equal to null, 2 is not equal to null. Root equal to p, 2 is not equal to p, which is 7, 2 is not equal to 8. This doesn't apply here. We recursively pass it to the left subtree. So after 2 we pass it to 0. Similarly for 0 also internally we check if root is equal to null, no. Root is equal to p, no. Root is equal to q, no. And then we call for its left and right subtree, which returns null to this one, which then returns null to this one, and which then returns null to 6, because either 7 or 8, neither 7 nor 8 was found in this left subtree. So we'll get null value from the left hand side. So if left is equal to null, and from right hand side we'll directly get the value 8 for 7 and 8, then right is our correct answer, right? Similarly, if right is equal to null, we can say return left. Simple. In the end, if both, as in this case, none of them is null, right? If both left and right subtree have valid results, by valid results it would mean non-null values. Valid results, the least common ancestor is the current root. So we can simply say return root, because we got 2 from here, we got 8 from here. Both of these values are valid. Neither left is equal to null nor right is equal to null, but we got one child in each of the subtree. That means current root node is the least common ancestor for them. Okay, let's see if we have another example. Here value of 2 is equal to p, value of p is equal to 2, q is equal to 4. Let's run this with our code. Let's do a quick dry run. So we arrived at root, the value is 6. Let me write it down. Let's remove here, let's create some space. So p is equal to 2, q is equal to 4, as mentioned here. So we arrived with root at 6. We checked if root equal to null, no. Root equal to p, no. Root equal to q, no. We passed to the left subtree, lowest common ancestor, root dot left, pq. So we passed 2, root dot left, 2 became a new root. Value of p is 2, value of q is 4. Value of p is 2, value of q is 4. 2 and 4. We already know from the image that 2 is the answer, right? Now 2 got called here. Then again we check root equal to null, no. Root equal to p, yes, root is equal to p, right? 2 is equal to 2, so we return root. So from the left hand side we got 2 as the answer for this subtree. Then in the previous call from 6 we are going to check for right. We pass 8, we check if root equal to null, no. Root equal to p, no. Root equal to q, no. Then similarly we'll call the same method, lowest common ancestor, on left and right child of 8, that is 7 and 9, and again it will not find anything. In the end, 7 is going to call its children node and it is going to return null to 8. 9 is going to return null to 8, and the end 8 is going to return null to 6. So left is equal to 2, but right is equal to null. So we'll check if left equal to null. No, value of left is 2. Is right equal to null? Yes, right is equal to null. So we are returning left, which is 2 for this example case, and that is our answer. Okay, I hope it was clear to everyone, but in case anyone has any questions, please let me know in the comment section, or if you see an approach better than this one, please let me know as well. Okay, let's submit and check. Okay, so we are actually performing really well, beats 100% of the users with Java. So I'm not sure if a better approach would be available with this one, but an easier approach for sure could be available. Okay, please take a minute and guess the time complexity for this approach. Okay, the time complexity for this approach is O of H. I'll write it here. Time complexity O of H. What is H? H is the height of the tree. H is this height of this tree. Okay, so with this we are done with our lowest common ancestor problem. Let's mark it done. Thank you everyone. That is all from today's video. Please like, share and subscribe.